Hey guys, it's your boy Mr. Wishart. Breaking it down on the ones and twos. That's not a thing I'm doing. I'm sorry, that was a lie. Anyway, as we're talking about linear associations, or scatter plots. Anyway, so our objective here. Let's see if I can focus this. My dot cam seems to be just fading and like going down. And you really need a screwdriver. Um, let's see. So, Angus has a big test coming up. Should he stay up and study or go to bed early the night before the test? Defend your recommendation. Use the graph if needed. So the idea is we're going to talk about paired data, which, paired data, I have time here versus percentage on the test. Where's this? Where's the document? It's just like moving here. Yeah, let's do it like this. Okay. And then we're going to talk about whether it's linear association, no association, or nonlinear, and then whether it's positive, negative, and strong or weak. So a few different things here, but it's fairly easy to understand. Okay, so for this one, I'm going to do time on our x-axis. Let's do bedtime. And I'm going to go by 15 minutes on this. This is still going. Oh, that's irritating. And then test grade on the y-axis. Okay, so I'm going to say that this is, let's see, time bedtime. I'm going to go by 15-minute increments. So I'm going to say this is 8 o'clock. Let's see, 15, 30, 45, 9 o'clock, 9:15, 9:30, 9:45, 10 o'clock, 10:15, 10:30, 10:45, 11 o'clock, right there. Okay, so 15-minute increments. I'm not going to label that, so hopefully you understand what 15-minute increments means. And then we're going to go up by, I think 2% is what I decided here. We're going to start at like 70 down here, right? So 70, 72, 74, 76, 78, 80, 82, 84, 86, 88, 90, right there. Sorry, guys, I do have a cold. And then I should have 100 at the top, but whatever. 92, 94, 96, 98, and 100 will be right there. Probably should have started at 60 because then that way I would have put. Gosh, guys, I am sorry. Yeah, just brutal cough. Okay. Okay, so went to bed at 9:15, got an 80%. So 9:15 is right here. 80% is right here for that first test. Okay. Went to bed at 10:30, got a 75. 10:30 is in the middle. And then let's see, 72, 74, going to be right in the middle, right there. Okay. Excuse me, golly. 11, got a 92, which is going to be, let's see, make sure I'm at 11. And 92 is going to be right there. 8:30 got an 89. Right in the middle right there. 10:45 got an 86. 10:45 right here. Is right there. Again, going up by twos on my y-axis. And then 9 got a 93. So 9 o'clock, 93 right there in the middle. Basically, should he stay up and study or go to bed early the night before the test? Defend your recommendation. Use the graph if needed. Well, I'm looking at this graph. We have this scatter plot right here with this limited set of data. Honestly, I don't think I can really draw any recommendations from this because I can't draw a line through this that makes sense, right? There's no association. So what I'm going to say, well, there's no association. Between Angus, I should have put somebody's name in here, my bad. Between Angus's bedtime, it could be different for another kid, and his test scores. So he can go to bed whenever. Okay. Strength of linear associations. This is when we're going to talk about strong versus weak. The Johanssons own an ice cream shop near the beach. Oh, man, missed opportunity there to put a name in there. Sorry, guys. The scatter plot shows their sales by daily high temperature. They then compare their sales by daily high temperature to the number of beachgoers. That's this one. Describe the associations shown. So the first one has daily high temperatures versus sales here. Okay, so that's this one right here. And then sales to number of beachgoers is right here. So if we talk about this one, we've got it's generally a positive trend right here. It's going up, right? So as temperature goes up, your sales for ice cream go up, right? However, this is kind of a loose association, right? Your data points are not super close to your line, so we would say that this is a weak positive association. Okay. So like just a way to define that. Well, we'll do that later actually. And then this one right here, beach visitors versus temperature. We have an outlier right here. Apparently somebody, yeah, that day was bad, I guess. Maybe it was like cloudy or pollution or whatever. I don't know. But anyway, this one we have the points clustered much more tightly around our line than we do in this one, right? So we would say this is a strong positive association. Okay, and we'll kind of define that later in the notes here on the second page. I think this is going to be a pretty quick one, guys. Okay, this is a nonlinear association, height versus time. I don't know exactly what height versus time means, but whatever. You can see that it's not a line, right? It's a curve, right? So how do you know this is not linear? Because it's a curve. Very easy to recognize. I'm trying to think here, like, is there even like a test question that like talks about this? Let me double check here. I'm gonna go through the test real quick. Yeah, no, all the associations we have in the test are linear. Okay, cool. All right. Positive versus negative. Does the scatter plot show a positive or negative association for the age versus value of a car? And I want to be very clear that this is not a classic car, right? So this this is not like a 68 Stingray or something like that, right? This is just an average, I don't know, like a Toyota Camry or something, right? So if you buy this car at 20 grand over the course of a few years, right, your value generally depreciates. That's what it's called, right? But we have this negative association, right? So this shows a negative association. So this graph shows a negative association between age and value of a car. Okay, and then we're going to have some visual definitions of what we've been talking about here. Positive associations is going to be something like this. So we can say this is increasing. A positive slope. Okay, negative association is going to be generally going down, so decreasing with a negative slope. Okay, and then no association is when your points are kind of scattered all over the place, right? So we'll say points are scattered all over. Okay, now we want to talk about strong and weak. Now you can have strong and weak negative, and you could have strong and weak positive, right? It just kind of depends on how closely your points are clustered together. So we'll do a strong negative for this one. Okay. Again, your points are clustered very, very tightly to your line through the middle, right? And we'll do a weak positive. Okay, this is when your points are kind of like all over the place, right? So clustered tightly. And then clustered loosely. Oops, sorry. So your points are clustered tightly to your line. Your points are clustered loosely to your line. That's strong versus weak. Okay. All right. An electrician charges an hourly rate, and an additional fixed fee is shown in the table below. How much does the electrician charge per hour? So we have the number of hours worked here versus the amount billed to the customer. So we'll figure out the pattern. We're going up by twos here. And then these are going up by, let's see, 200. Oh, this should be, oh, I should change that. I'm going to say that's 90 rather than 190. My bad. Yeah, so, oh, I'm going to shift these totally. 200, 310, 420, 530. Sorry, guys, my bad. Okay, so we're going up by 110 each here. Okay, so we take this 110, this is our rise over our run. Okay, so this is our slope basically, right? So rise divided by run is going to be 110 divided by 2. Okay. Okay, 110 divided by 2 is 55. So the electrician charges $55 per hour. That's a bad 55. Ugh, God, I can't write today, guys. $55 per hour. And I can't get it on camera either. So you take your 110, you divide by your 2 is your rise divided by your run, you get 55. So the electrician charges $55 per hour. Okay, there you go, guys. Thank you.